All right, so when we're substituting, remember that we need to have an x or a y by itself to start out with. So looking at the two equations given, this one right here is already has an x by itself. So I know that x is going to be half y plus 3. So I'm going to substitute that into the second equation when I see an x. So I'm going to substitute, instead of putting an x, I'm going to do half y plus 3, and then finish writing the rest of that equation. All right, so now I'm going to distribute the 2 onto these two things. So half of 2 is going to be 1y, and 2 times 3 is going to be 6, minus y is equal to 6. All right, so when we combine like terms on the same side of the equal sign, I have a negative y and a positive y. So I know that those are going to cancel out. So I'm left with 6 is equal to 6. So if I have 6 equals 6, that's a true story. So if I have 6 that really does equal 6, or a number really does equal a number, then you're going to have infinite solutions. For example, if you had like 6 equals 7 was your answer, that's not a true story. So in the event that you have 6 equals 7, or something that doesn't equal itself, then this would be an example of no solutions. So looking at number 4, we're going to substitute. We need to find either an x or a y. It's going to be the easiest to get by itself. So looking at the top equation, that one's going to be easier to get y by itself because I don't have to divide everything by like a 5 or a 4 like I would on the bottom equation. So all I need to do here is subtract the 3x over. So let's take a look at what that looks like. All right, so we're going to subtract the 3x over. Now we're left with negative y is equal to negative 3x minus 2. And we don't have y by itself yet because we have to divide everything by negative 1 or just change the signs of everything. But that's going to be y is equal to 2 negatives make a positive. So that's going to turn into a positive 3x plus 2. All right. So now that we have a y isolated, we need to plug that in into the other equation. So we're going to plug this in for this y and solve for our x. We'll do that in different colors. Run out of room. All right, so 4x plus 5, but instead of putting my y, I'm going to substitute my 3x plus 2 equals 48. All right, so I need to distribute this first. So 4x plus 15x plus 10 is equal to 48. I've got like terms here, so that's going to give me 19x plus 10 is equal to 48. Subtract the 10 over, leaving me with 19x is equal to 38. Divide both sides by 19, and x is going to give me 2. All right, so now I can go back into the other equation and plug that in. I'm going to plug it in right here. So 3, instead of putting my x, I'm going to substitute a 2 in. Minus y is equal to negative 2. So now I'm going to solve for my y. So 6 minus y is equal to negative 2. If I subtract my 6 over, I'm left with negative y is equal to negative 8. So I can divide both sides by negative 1, leaving me with 8 is equal to, y is equal to positive 8. All right, so then my final answer would be my x and my y put together. So 2, 8 would be my solution for that substitution problem.